So today is the 16th of December 2024.
So we said by default range creates a list starting at 0. However, if we call range with 2 inputs, we can create a list that starts at a different number. For example, range 2, 9 would generate numbers starting at 2 and ending at 8, just before 9. And remember, if you want to print your range, you have to listify it, so you have to print the list function applied to that range. Length. Often we need to find the number of items in a list, usually called its length. We can do this by using a built-in function called len. When we apply len to a list, we get the number of elements in that list. So if we have my list, and it's 1, 2, 3, 4, 5, and we print the length of my list, then we will get 5 as the output. Let's find the length of various lists. Calculate the length of long list and save it to the variable longlistlen. So you can see here we have long list, and we have the assignment operator, and we've assigned to it quite a big list, and there's lots of different data types in here. We've got some numbers, that's an integer, we've got a float, we've got a boolean value, and some strings. But it says save it to the variable long list length, so long list len has assigned to it len of long list, and I think that's all we need to do. It doesn't say print it. Perfect. 2. Use print to examine long list len. So I'm going to do print long list len, print the name of my variable, and it comes out with 18, which is right because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 elements in the list. 3. We have provided a completed range function for the variable big range. Here we have big range, and we've assigned to that name range to 3000, and each element is going to stand for 10 elements, which means 10 itself won't be included. And so we go from 2, there's our unwanted upper. So we've completed a range function, calculate its length using the function len, and save it to a variable called big range length. So I'm going to say big range length has assigned to it len of long list len. Note: range objects do not need to be converted to lists in order to determine their length. It's helpful to know that because we know that we do need to convert range objects to lists if we want to print them. What have I done wrong? Have I saved it to a variable called big range length? Yep. No. Read the instructions. We have provided a completed range function for the variable big range. So I need to calculate the length of big range, not long list length. So big range. So think about what you're calculating the length of. There we go. And now use print to examine the big range length. Print big range length. And it's 300. 5. Change the range function that generates big range so that it skips 100 instead of 10 steps between items. How does this change big range length? So big range, I'm going to change it so that instead of this being 10 here, I'm going to make it 100. That's the step between everything. And of course that means there's 99 things between each element, 99 sort of imaginary elements between each element. How does this change big range length? Well, if I print big range length, big range length, I'm just going to provide some helpful string here to print. I'm going to print a string that will be a bit more helpful, and then comma, and then control enter. Now big range length is 30 rather than 300, and that makes sense because if you think about it, we're going from 2 all the way up to 3000. If you think about 3000, well, if you divide it by 10 you get 300. If you divide it by 100 you get 30, so big range length is 30. Slicing lists. In Python, often we want to extract only a portion of a list. Dividing a list in such a manner is referred to as slicing. Let's assume we have a list of letters. So letters has assigned to it A, B, C, D, E, F, G. Suppose we want to select from B through F. Remember, this through word relates to things and includes them. So B through F means everything between B and F and F itself. So we don't want A, we don't want G. We can do this by using the following syntax. Letters, and then in square brackets next to letters, the name of the list, we're going to put start, end. Where start is the index of the first element that we want to include in our selection. In this case we want to start at B, which has an index of 1. Remember, it's the index of the first element. You don't name the first element. And end is the index of 1 more than the last index that we want to include. The last element we want is F. We do want F though, but it's the last one that we do want. That has an index of 5, so end needs to be 6. Again, it's this idea of the unwanted upper, just like when we're using the range function to generate lists. So we're going to assign to sliced list letters, which again, that's the name of our list, letters, and then we're going to put 1:6. So we're going to get the first element, not the 0th element, but we are going to get the first element all the way up to the 5th element. Altogether now, the 5th element, good. And then print slice list, and then we'd get B, C, D, E, F. So A is gone, G is gone. Notice that the element at index 6, which is G, is not included in our selection. 1. Use print to examine the variable beginning. Before hitting run, think about what elements beginning will contain. So we can see here we've got a bit of code pre-provided, let's say, for us. Suitcase is a list, that's the name of our list, suitcase, and it's got shirt, pants, pajamas, books in it. And then we do suitcase 0:4, so we use this slice expression. And now if I think about that for a minute, we've got the 0th element being included, which is shirt. The 4th element, that's the unwanted upper, so we won't have 0th, 1st, 2nd, 3rd, 4th. Pajamas will not be included. That's the unwanted upper, so we're going to get 4 items: shirt, pants. So print beginning, run, and yeah, we get shirt, pants. Pajamas is missing and books is missing. 2. Modify beginning so that it selects the first 2 elements of suitcase. Well, all I'm going to want are the 0th and 1st element, and I need to name an unwanted, a sample of what I don't want, so that will be the 2nd element. So 0:2, run, 3. Create a new list called middle that contains the middle two items, pants and pants from suitcase. So I'm going to say middle, and we're going to assign to that, well, it is suitcase, but it's a modification of suitcase. Pants is the second item and the third item, so 2:4. And then I'm going to print middle. New line, and I'm going to say middle, colon, and then print middle. Control enter. And now we've got pants and pants in middle. Perfect. Slicing syntax in Python is very flexible. Let's look at a few more problems we can tackle with slicing. Take the list fruits as our example. Fruits has assigned to it apple, cherry, pineapple, orange, and mango. 5 elements. If we want to select the first n elements of a list, we could use the following code. We could say fruits and then put :n, and that's like everything up to n. We've kind of left the lower bound as implicit, haven't we? We haven't explicitly put a lower bound. For our fruits list, suppose we wanted to slice the first 3 elements. And presumably when they say to slice, they mean extract the first 3 elements so that we have the first 3 elements. The following code would start slicing from index 0 and up to index 3. Note that the fruit at index 3, presumably they mean the third item where there's a 0th and a first and a second, so the fourth one really. The fruit at index 3, orange, is not included in the results. Again, the unwanted upper. So if we do fruits, :3, we're going to get the 0th element, the first element, the second element, but the third element is unwanted. So we get apple, cherry, pineapple. Right, we get apple, cherry, pineapple. There's no orange or mango. We get that by doing just :3 in the square brackets. There's kind of 2 contrasting principles at play. First, we have zero-based counting, and that's occasionally counterintuitive. Intuitively, you might go 1 and say that's the first position, 2 and say that's the second position, 3. So we have to remember that Python is slightly counterintuitive in that we use zero-based counting. We have the 0th, first, second, and then there's a second principle that's counterintuitive, and that's the idea of the unwanted upper, the fact that the number that you mention is actually not the upper bound that you want included in the output, but the unwanted upper. And both of these principles, zero-based counting and the unwanted upper, act in opposite directions. Zero-based counting means that cherry is lower than we might think, because you might think cherry is 2 here, or is second, but it's actually first. So zero-based counting acts in that direction on our intuitions, and then the unwanted upper, you might say, acts in the opposite direction, because if we say, let's say we understand zero-based counting and we say, okay, 0 is first, second, and so we want pineapple in our output, so we put 2 as the upper bound. Well, actually, the unwanted upper kind of pushes the list that gets outputted down and inward, so that if we were to say that 2 is our upper bound, we wouldn't get pineapple in the result. We'd only get apple, cherry. So you can see these 2 principles at play, and they kind of act in opposite directions. We can do something similar when we want to slice the last n elements in a list. If you put -n : you will get the last n elements, so negative number : for our fruits list, suppose we wanted to slice the last two elements. This code slices from the element at index -2. Now remember, the last thing is always -1. So anyhow, this code slices from the element at index -2 up through the last index. So if we do the print function and then fruits -2 colon, well, because it's before the colon where we've placed a number, it's as if we're using a lower bound, and we are, but we're also using negative counting here, aren't we? The point is, if you put -2 colon, you would get orange mango. So if we look at the original list, we'll get these two things here. That makes sense. If we just put -1, we'd just get mango. If we put -2, we get both of these items. If we put -3, we get all three items. And it's -2 colon. It's not colon -2 because we're so we're giving a lower bound, and I suppose that is quite strange. Because you might think we should actually say what we're doing is going from 0 all the way up to -2 or -2. So it's the upper bound we're providing explicitly. But actually, no, it's as if, I think it's because we're using negative counting that actually we put -2 before the colon. So it's fruits -2 colon, as if it's a sort of lower bound that we're providing. Negative indices can also, positional numbers that denote positions, can also accomplish taking all but n last elements of a list. Let's read that again. Negative indices can also accomplish taking all but n, so all but a particular number of the last elements in a list. So you might see colon, so we kick things off with a colon, which is, we've not seen that before, colon -n, or dash, yeah, -n. Let's explore this. For our fruits example, suppose we wanted to slice all but the last element from the list. Again, to slice, meaning to, it's as if you, when we say to slice, I don't really like the way they talk with this way. I would rather that, but because slice is, it needs an object really. Slice what? What do you mean slice? But they're using it to mean extract. So it's as if someone is, if I said slice the pineapple, what I mean is go and carve yourself a little chunk out of the pineapple to take away, to eat. So this example starts counting from the 0 index up to the element at index -1. So colon -1. So it starts counting from the 0 index, the 0th index, up to the element at -1. And as we know, the element at -1 is the last element. Right. So I think that's quite intuitive for me. So it's as if because usually we have lower bound, colon, upper bound. So because we just have colon, upper bound, we've missed out the lower bound. There's no lower bound actually mentioned there, because there's nothing before the colon, is there? So the lower bound just is 0. The thing before the colon is 0, and then we have an upper bound of -1. Unfortunately, the idea of the unwanted upper doesn't come into play here. Again, in a way, this I think is strange. This example starts counting from the 0 index up to the element at index -1. So you've just got to get used to that. Actually, will it include the last item? Because we've said -1. We've said -1. It's explicit. And usually, when you make the upper bound explicit, that's what's not included. So I'm interested. If I do suitcase, if I print suitcase and then take a slice, colon -1, will I get the last item? Will I get pajamas, books? Or will it do the unwanted upper thing and say, well, you've said -1, so we're actually only going to go shirt, shirt, pants, pants, pajamas. Let's have a look. I think it'll include it. No, it doesn't. Correct. So, yeah, good. Yeah, so it's really this. So the unwanted upper does apply here, and in fact, it's this English wording that's a little bit confusing when we convert what the code does into words. The words are, this example starts counting from the 0 index, meaning 0 is included, so we do have shirt, up to the element at index -1. And I think that's always a little bit ambiguous, up to, because do you mean the index at -1 is included or not included? It's ambiguous. Up to the element at index, up to the element, and then we have some noun phrase, the element at index -1, up to, and then a noun phrase. Does that mean that does get counted? In this case, yes. So so it's just making sure we have we are calibrated in terms of how English expressions translate into the logic of things. Again, there's another phrase that's ambiguous, x through y. If I say 2 through 10, that means 2, yes, and everything in between 2 and 10, and 10. That is inclusive. So let's practice some of these extra slicing techniques. Okay, let's remove that. Create a new list called last 2 elements, containing the final 2 elements of suitcase. And then print last 2 elements to see your result. Okay, so first let's create the list. Last 2 elements, and I'm going to assign to it the final 2 elements of suitcase. So start by just saying suitcase, and then let's have a think. The final 2 elements. So we've got a few choices to make here: positive counting or negative counting. We could do it with positive counting first. So 0th first, second, third, fourth. So I'm going to put 4 up, and then we want the 5th, so I'm going to put 6. So that's one way of doing it. And then if I print last 2 elements, we should get a list with just pajamas and books. Oh dear. No, 0th, first, second, third, fourth, 5th. You need to put 6 there, the unwanted upper. Run pajamas books. There we go. And let's now try an alternative way of doing it. So I'm going to use a comment, alternative way of doing it, just to get in the habit so that I, despite myself, start using comments when it really matters. Last 2 elements, we could say last 2 elements has assigned to it suitcase, but this time I'm going to use negative counting. So here's one way of thinking how it might work. I don't know, is this correct or not? You might think, well, we go from the last one, -1, up to -3. So we have -1. That's books is in position -1, -2, and -3. And the reason I mention -3 is not because I want 3 items in the result, but because I'm using the unwanted upper. And if I print, I'll call it alternative method, and do \n space and then input last 2 elements, you'll notice that I'm printing the same variable name as I did before, and that's okay because we are feeding in a new expression as the value of last 2 elements on this line, and because this line is positioned later in the code than this line, after the first print statement is executed, that's fine. The Python interpreter doesn't retrospectively then change the first print statement with its knowledge that on later lines, last two elements is given a differing value. It doesn't work like that. Unfortunately, it hasn't worked. Alternative method, we just get some blanked out square brackets. Okay, so what went wrong? Well, what if I just put -1 colon? I get books. Yeah. What if I just put -1? I get books without any square brackets again. So -1, run, books. If I do colon -1, so that's a good point. Maybe sometimes you want the output to be in square brackets, so just put colon -1, yeah? So you type colon -1, run. What? Okay, let's try, what if I put -2, comma -1? Can I do that? Pajamas. Okay. So it's given me the second to last one. What does that tell me about how the syntax works? It tells me right, okay. You think that because you're using negative numbers, we count from this end, but we don't. We still slice from left to right. In other words, we still go, right, imagine this is a big pineapple and you come with a knife to cut yourself a chunk out. What you're going to do is you cut a square, so the mouse is a knife, so I go, and then I go across, and then complete the cube. Honestly, imagine it's a pineapple. And that's how it works with slicing. So we start lower on the left of the list, somewhere on the left of the list, go, and then we move to the right, and then we make the second cut somewhere further along the right to the list. Now it could be here, take the whole list, it could be here, go to the right, take that bit, it could be right at the end, the left slice and then the right slice, or the further to the right slice. And that's how we do it, even when we're using negative numbers. Don't think that because we're using negative numbers we go chop, chop. We don't sort of do the right hand slice and then the left hand slice. We still go from left to right. So if I want to do it using negative numbers, so I'll call this hash using negative numbers, I still, right, so I'm going to put square brackets and colon, right, and I know I'm going to have to put something before the colon and something after the colon. Right, so before the colon, don't be thinking, where am I going to make my right hand slice? Should I start here and then cut and extract all the way up to here and take those 4 items? Wrong way of thinking. You need to think about, if you're thinking about what goes before the colon, your left hand cut. So you need to somehow say, I want pajamas for the left hand cut, because that's the slice we want to make. We want to go, right, as if we're cutting a cube out of a pineapple. So I need to denote pajamas somehow. I need to refer to that. Well, we refer to it using our positional identifiers, our indices. So what's pajamas? Well, we know this is -1. Whoops, we know this is -1, so this is -2. So we refer to pajamas, the left-hand cut. So I put -2, and then I need to refer to my right-hand cut, which is -1. Oh, but then we have unwanted upper. Remember, I want books to be included. I want to go, look at where the chop goes. So around books. I want to go round pajamas and around books so that we have pajamas and books in our output. Now usually that means the unwanted upper means I'd name the one after books. But what do I name here? Do I put 0? Yeah. If I put -1, I think that wouldn't be included, because the tradition is you name the unwanted upper. The rule is you name the unwanted upper. So if I put -1, I'd only get pajamas. Let's test that. So at -1, run, correct, you only get pajamas. So what do I change it to? Well, just keep counting that way. -2, -1. What comes next in the number line? 0. Good. So put 0. Run. But it doesn't work. And that does confuse me. That does confuse me. Why doesn't that work? So let's investigate that. So, good afternoon. I'm thinking about Python lists, Python slices. I'm trying to get my head around the logic of it. Specifically, I'm wanting to work on a list which is called suitcase. Control C, Control V. I want to output the final 2 items in this list, in the list. So pajamas, and books. To challenge myself, I want to use negative numbers to do this. Now, if I use the index expression, or let's just say the expression suitcase and then just put -2 colon. Oh, what did I put? -2 -1. So if I put -2 colon -1, -2 colon -1, then I get pajamas outputted. In other words, I get the second to last item outputted. Now, I understand that this is because -2 selects the second to last item, pajamas. Then, because of the way ranges work in Python, you use the unwanted upper principle, naming the upper bound so that what you name is not included in the output. Because the upper bound here is -1, the -1 item, namely books, right, is not included in the output because the unwanted upper is not included in the output. So because the upper bound here is -1, so that's my reasoning for why we get this output. So here's my question. Surely then, if I replace the -1 in my expression with 0, I should get the final item included. That is, my output should be pajamas, books. Unfortunately, though, this is not what I get. Can you explain this? Good afternoon. You're on the right track in your reasoning about Python slices, and your understanding of the unwanted upper principle is spot on. Let's clarify why suitcase -2, 0 doesn't behave as you expected, because it doesn't. Right, so I have -2, just again, to recap really quickly, I have -2 -1, and I get just pajamas, right, run pajamas, and then I think, and I know that -1 is selecting for books, that is -1 position books. So if I just crank that to the right and change -1 to 0, I should now get the right-hand chop being over here, and books should be included. Run, but it isn't, so explain that. So here's the key insight. In Python slicing, negative indices work relative to the end of the list, but positive indices still refer to positions starting from the beginning of the list. The important part is how the slicing range is interpreted. -2, it's true, it does refer to the second to last item always in a list. But 0 doesn't refer to the imaginary item beyond the last item. 0 refers to the first item in the list, and even though you've used negative indices for the start index, 0 is still understood as a sort of number just before the positive numbers start. 0, yeah, still refers to the first item in the list. And this will help us to understand the behavior of suitcase and then -2 : 0, which is what we tried. When Python evaluates the slice suitcase -2, 0, it tries to include elements starting at the second to last item and ending before the first item, which is shirt. Since the slice is attempting to move left, as it were, from a later index, -2, to an earlier one, which is 0, it produces an empty list because Python slices only move from left to right in increasing index order. So the piece of information we lacked, which meant we were confused by this result, is the fact that 0, how can I put it? Yeah, 0 is to the left of -2. You didn't realize that 0 is kind of a positive number, and therefore what you're doing is putting a number on the right and following that by a number to the left. So you're slicing backwards. You're not following that rule of starting on the left with your lower bound and then moving to the right for your upper bound. So the correct slice. To get the last two items using negative indices, you should use -2 : and then nothing. So it's not just being kind of, isn't it elegant and clean if I don't actually even need to mention the upper bound. I can just put -2 : blank. It's not just elegance, you really do have to leave it blank. There's nothing you could explicitly put to refer to the upper bound here, because we're at the boundary between negative numbers and positive numbers. That's what 0 is. So as soon as we start naming 0, we've sort of reached the point where we're now referring to this item. So we have to put -2 : nothing. So we put suitcase -2 : but I suppose if you're reading it, you can imagine that we're referring to, the right-hand side of the list. -2, it refers to the second to last item. There's no end index, and this implies go all the way to the end of the list. So suitcase -2 : will output that. So the general rule of thumb, start index is inclusive, the end index is exclusive, the end index is exclusive, end exclusive. If the start index is greater than or equal to the end index, which is weird, right, greater than the end index, then the result will be an empty list, and that's what we experienced. All right, if we put -2, 0, then what we've done is put a later number followed by an earlier number, and that's why we get an error. Pajamas books. So that's 1, tick. 2. Create a new list called slice of last 3, containing all but the last 3 elements. Print slice of last 3 to see your result. I can't really remember how to do this. Slice of last 3. And it's going to be equal to suitcase printing containing all but the last 3 elements. So this one, this one, this one, and that's it. Let's get a hint. Negative indices can help accomplish taking all but n last elements of a list. So we can put colon, negative n. Let's experiment. So if I put colon -2, and then I'm going to print that. So if I put colon -2, I get shirt, shirt, pants, pants. Shirt, pants, pants. So I've got everything apart from the last 2 items. Now why? Because it's as if we've missed out the left-hand slice. Which means it becomes just the start of the list. And yeah, you can see we get shirt, shirt, and shirt, shirt starts at the start of the list. And then -2, well, that will always refer to this second to last item, because it's just a fact that that is -1, that is -2. But we have the unwanted upper, so the actual -2 content is not included because of the unwanted upper. So it's start of list up to colon -2. So if I go colon -3, run, now we've got shirt, shirt, pants, run, containing all but the last 3 elements. Did you print slice of last 3? Yes, I did. What's interesting about this is that if we put -3, we do get 3 items in the result, which is like normal, like, because usually when we mention a number, we don't get that number, you know, the unwanted upper and so forth. What's happening here is we're giving an upper bound, the thing after the colon, we're putting -3, and yet we are getting 3 things. So it's as if the unwanted upper doesn't apply here with negative indexes. And it's because partly zero-based counting doesn't work. You know, that is not the zeroth element, as we've learnt today. That is -1. That is -2. So zero-based counting doesn't work when we're going from right to left. You might think of it that way, but we do use it here. That's zeroth, first, second, third. Okay. Create a new list called slice of last 3. Yep. Containing all but the last 3 elements. Oh, yeah, all but the last 3, so no pants, pajamas or books. It said you can use negative indices, colon, negative number, well we are. If we want a slice containing all but the last 3 elements, what would n be? -3. I don't know why this is not maybe I need to just, yeah, what we did earlier is we used two methods, your code below. We wanted to get Pyjamas books, the last two elements, and we could either do 4 to 6 using positive numbers, or we could say -2 and then just don't say where you're going to stop on the right hand side. So it's as if we start, -2 to this way, so we could use negative numbers for our referring scheme, because of course it's just a scheme we're laying on top. Pyjamas is always pyjamas, but if we use one scheme it's 0, 1, 2, 3, it's number 4. If we use another scheme it's of course -2. So pyjamas, it's like that, every element has 2 hats it can wear. It is 4, but it is also -2. If we use positive numbers, we start with 4, we do 4 colon 6. If we use negative numbers, we do -2, -2. So it's always pyjamas in the lower bound. But remember, 0 belongs to the positive numbers. So maybe I need to get rid of this block and then it'll give me the tick. Actually, I will just keep the one where I use the negative numbers. I like that. I'll get rid of my annotations. I think, yeah. Maybe I need to remove that. Okay, now I've got the tick. Okay, good. It's funny because it says you can get a code review, and the code review says make it more readable and print strings, but then you can't get the tick. That's fine. Okay, next. Counting in a list. In Python, it is common to want to count occurrences. Another word, notice the spelling, oc, the occult, OCC, get that right, and a double R. Occurrences, current, currency, it's got currency in it. So it's double R and a double C. In Python, it is common to want to count occurrences of an item in a list. Suppose we have a list called letters that represents the letters in the word Mississippi. Another word, notice the spelling. M-I-S-S, so you can imagine there's the word miss within there. Missy, Sippy, S-S-I-P-P-I. So double letter, and double letter, Mississippi. And so every letter of the word Mississippi is an element. M is an element, you can see that here, I've highlighted it. The I is the next element, S, S, I, S, S, I, P, P, I. I said we have 3 pairs of letters, so S, S, where the pair is consecutive, S, 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 and P, P, so bum, bum, bum. And that means that overall we have 4 S's, because 2 of those pairs are S's. So this is a really good example because we've got a lot of elements where the element is the same content. So we've got 4 S's in here. If we want to know how many times I appears in this word, think 4. So you've got Missy, that's 2. Sippy. You can think of the whole word as really 2 segments, Missy and Sippy. So it's quite structurally similar, aren't they? It's a 2-syllable phrase with an E at the end and an E at the beginning. I, E, I, E. So if we want to know how many times I appears in this word, it's 4, we can use the list method called .count. So we could do num_i, that's a new variable, we haven't had that so far, we've called our original list letters, and we're going to assign to that letters.count and put in I. And then if we print num_i, it would output 4. Notice that since .count returns a value, we can assign it to a variable to use it. Notice that since .count returns a value, we can assign it to a variable to use it. What do they mean by that? Well, the thought is that not all methods return things. But it's just strikes me as confusing. But because a lot of the methods we've looked at so far do return things, so it just seems a bit strange to say that. But yeah, it might be that we can do .count and the method just I don't know, maybe it's saying that because there are some, there must be some methods that don't return a value. Maybe they return something else, or maybe their output is just to change letters, the thing that they are called on. So maybe if I do object.method, it just changes the object. It doesn't actually, and that is the output, the change to the object, right? There's always be an output because a method is an example of a function. .count is a function, and functions always have outputs. But it's just that maybe the change to the object is the output, and it's not the case that the method returns a value. But they're saying that that fact that .count does return a value, that is linked to this ability to say, okay, well, let's assign that to a variable num_i and then print the result. We can even use .count to count element appearances in a two-dimensional list. Let's use the list number collection as an example. Number collection has assigned to it this two-dimensional list 100, 200, 100, 200, 475, 29, and 34, 34. If we wanted to know how often the sublist 100, 200 appears, and it appears twice, you can see 100, 200, 100, 200. What we could do is we could do number collection, the name of the list, .count, number collection .count, and then feed in the list that we want to see how many times it appears in. And then if we print the result of that, or the variable that denotes the result of that, num pairs, we'll get 2 as the output. It would output 2 because we have 1, 2 instances. It doesn't ever appear again. Let's count some list items using the .count method. Instructions. Mrs. Wilson's class is voting for class president. She has saved each student's vote into the list votes. Use .count, the .count method, to determine how many students voted for Jake and save the value to a variable called Jake votes. So I'm going to say votes. I can see we've got a votes list. Votes.count. And I can just through common sense see that it wants me to see how many times Jake is mentioned as an element, is used as an element in the list. So I'm going to put Jake, because it could have been that the elements of the list were Jake, 16 votes, Laurie, 10 votes. So it's votes.count, and then what I can do is I want to, because this isn't how I'm starting to think now, because I want to refer to the work done here, you know, make use of this variable, I need to kind of wrap it up in something, because I don't want to say, okay, in the next line I want to do print, or we'll have to type it out again, print votes.count, but crucially I could do that, okay? That's the point, realising that there are things you could do that are stupid. So you could do print votes.count Jake, and you know, it works. We get 9, we get an output. But the thought is, it's more intelligent to say, well, let's abstract that. Let's sort of signify that value with Jake votes. And the thought is there's just something better about doing it this way, and then refer to Jake votes rather than those characters that we typed out before. And that's Jake singular, Jake votes. Okay. Use print to examine Jake votes. What? Yeah, good. Okay. Okay. So that was counting in a list, and we're on lesson 9 out of 12. Let's leave it there.